Yesterday, out of nowhere, OpenAI announced a $38 billion 7-year compute deal with Amazon Web Services. And yes, that's the same OpenAI that's been tightly linked with Microsoft for years. This isn't a soap opera, it's an infrastructure coup. It is November 4th, 2025, and you're watching the Daily Dose of AI. The AI world looks like three things mashed together: giant models, scarce chips, and even bigger contracts. OpenAI's AWS deal commits tens of billions for cloud services over 7 years and aims to deploy capacity throughout 2026. This signals a clear shift. Labs are diversifying compute across clouds to avoid single vendor limits and to secure more capacity. Anthropic, the Claude folks, recently struck major chip cloud deals with Google for up to 1 million TPUs, worth tens of billions, and is scaling capacity into 2026 as well. So this is industry-wide, not an OpenAI solo stunt. Previously, Microsoft poured cash and Azure credits into OpenAI, which created a perception of exclusivity. But contracts, reorganizations, and the basic economics of supply shortages mean no single cloud can handle all the demand. OpenAI is now playing the multi-cloud game, not because they're romantic, but because GPU scarcity plus price leverage equals survival. The problem is, these deals make compute a bargaining chip, and that redistributes power from model creators to cloud owners who sell chips and data center scale. That's the actual strategic prize here. Training versus inference. Training still tends to use NVIDIA-style GPUs or specialized TPUs for large-scale parallelism. Inference can migrate to more cost-efficient accelerators, AWS Trainium/Inferentia or Google TPUs, depending on model architecture and precision optimizations. Don't assume one chip fits all. Timeline and scale. OpenAI will start using AWS immediately and aims to bring full targeted capacity online by the end of 2026. Contracts let them expand beyond that window. This isn't instant. Migrating billion token services is a months-long ops project. NVIDIA H100OS, very flexible, industry standard for large model training. Google TPUs, optimized for some matrix multiply workloads, cost-effective at extreme scale. Anthropic signed for up to approximately 1 million TPUs. AWS Trainium/Inferentia, designed for inference and some training workloads. AWS positions them as cost-efficient alternatives for production inference and specific training patterns. AWS/Anthropic messaging. Benchmarks vary by workload. Don't claim blanket superiority. These mega contracts secure committed spend and guaranteed capacity, which lowers deployment risk for model owners but increases vendor lock. For devs, shorter SLAs, regional deployment, and dedicated stacks matter more than raw chip counts. Expect cloud providers to monetize reliability and co-development options. Centralization risk. Mega deals funnel more of AI's stack under a few cloud vendors. That's efficiency, yes, but also concentration of failure modes and geopolitical leverage. Regulators will notice. NVIDIA's position, still central for many training workflows, but alternatives are gaining real production stories, meaning pressure on NVIDIA's margins and supply dynamics. Open source hedge. Smaller orgs will continue using model compression, quantization, and community runtimes to avoid the big cloud tax. That trend won't disappear just because of one big deal. These partnerships also accelerate product stability and enterprise adoption. If you're building a mission-critical product, guaranteed capacity and vendor integrations can be a no-brainer. Benchmark your workload on alternatives, GPU versus TPU versus Trainium. Don't take marketing at face value. Plan for multi-cloud optionality if your product can't tolerate vendor outages or sudden price shocks. This $38 billion deal is massive, but it's not magic. It's about capacity, cost predictability, and strategic positioning. Expect more of these deals, and expect them to shape who profits from the AI boom more than which model is objectively better. Smash the like and subscribe, and tell me, are we building smarter AI or just richer clouds?